He was when I first met him, he was a staff scientist at the National Institute of Standards and Technology. And he was there for a good long time. He only transitioned to Johns Hopkins in this past summer. And so what Kamal has built his career on doing is creating transparent and open science for the community. While he was at NIST, he maintained Jarvis. Some of you may have used Jarvis in one of your previous assignments for his DFT calculations. Um, from my own experience, it is probably the most diverse DFT data set. It's the hardest to learn with the least amount of data. You need like 70% of Jarvis to get a good model, which speaks to each data point carrying a lot of information. Beyond DFT, beyond that DFT data set, Jarvis was a whole constellation of computational material science tools and data made freely available to the community. In addition to that, he worked with Brian DeCoste to build the Align graph neural net model, which was for a period of time the number one performing graph neural net model on all of the benchmarks, computational benchmarks. Um, Kamal is amazing. While he was at NIST, he had a collaborative network of hundreds of people, super productive as an individual staff scientist, often publishing on the order of like 20 papers a year as author and co-author. Um, has had a really great nose for what are the up and coming topics and how to ask good, interesting questions that can be addressed quickly. Um, Kamal, I'm really looking forward to your presentation. And please, the floor is yours.
Thank you, Jason, for the kind and very humbling introduction. It's great to be part of this symposium series. Hello, everyone. Hopefully, I'll be able to meet in person, but today I have a chance to meet you virtually. I was asking Jay the other day, what topics should I select? Or what are you guys studying? So he just gave me a free roll. So I selected one of my recently favorite topic called agentic AI, especially for material design, and that's what I'm going to talk about, especially with a new infrastructure that I have recently developed called atomgpt.org. Specifically, it's like a AI chatbot for materials design. And as Jay mentioned, I'm an assistant professor at Johns Hopkins University with affiliations on material science engineering, ECE, and DSAI. I still have my research associate position at NIST. This is the outline from my talk. 4 bullet points or 4 points. First, I'll discuss what is agentic AI. Then I'll talk about a framework called ChatGPT Material Explorer. Then atomgpt.org as a open source version or open source successor of ChatGPT Material Explorer. And then we'll talk about benchmarking and hackathon exercises along those lines of agentic AI. So let's start with overview of agentic AI. But before we go there, I thought this morning we were talking about some interesting things. So I thought I'll put a slide on what is intelligence. So if you look into the definition of intelligence, there are several papers. For instance, Universal Intelligence by Legg and Hutter, Charlotte on the Measure of Intelligence, Sternberg on the Cambridge Handbook of Intelligence, and Pearl, the Book of Why. All of them are fantastic read. Feel free to take a look, at least one of them. It will clarify what intelligence is and what intelligence is not. Intelligence is usually considered as ability to adapt compared to memorizing. So, in not just interpolation, but sort of extrapolation. Reasoning, um, uh, learning only from few examples, and there are several measures such as Stanford Binet test, IQ test, and Turing test to measure intelligence. But still, what really intelligence is not super clear, especially from a quantitative perspective. Also, from neuroscience perspective, intelligence is not very clear. Although it has been considered as one of the waves in brain. So there are, you might know there are 5 waves in brain. delta, theta, alpha, beta, gamma. So this is considered with gamma waves as intelligence. So what's the counterpart of gamma wave in AI? It's not very clear. So a lot of things are unclear. So that's also leads us to opportunity to learn about intelligence. I'll not spend too much time on this, but would like to point out different landscape of AI. So AI is usually a broader umbrella term, and machine learning is a specific field in AI where we'll deal with data on the order of 500 data points, smaller data points. Deep learning, on the other hand, deal with much larger data sets, such as all the images and text and other documents that we received from Wikipedia and so on. So that was deep learning based models, larger data sets on the order of 1,000 or more. Generative AI or Gen AI is a framework where we can create new content, and agentic AI is a next generation modern way of connecting high fidelity tools with generative AI. So Gen AI plus tools is kind of agentic AI. It's kind of a human in the loop process to get the accuracy in your AI predictions. So why do you need agentic AI? There are several limitations of material design, especially material discovery is super slow, expensive, and fragmented. There are several databases, and we manually have to stitch them together to solve a particular problem, like find papers, find some data points from Jarvis or whatever other resources you have from your experiment. These are quite fragmented, so put it together with agentic AI. Traditional AI predict property but cannot act by itself. It's not driving force. Scientific workflow require multi-step reasoning, tool chaining, which cannot be which is can be tedious to do everything one by one. So can we actually create a junior scientist with AI, and that would be our agentic AI framework. Also, uh, LLM or generative AI models often hallucinate for with high confidence for specifically tasks for materials and chemistry and physics, biology. Psychophancy is there, and there are many models out there which are proprietary, like ChatGPT, Claude, and so on. There are black boxes models. Their results are non-reproducible. So you ask a question right now, tomorrow, or even 3 minutes from now, if you ask the same question, you might get different answers, which is not good for science. Science demands reproducible answers. So agentic AI, what it does is it uses the brain of the model as LLM and then uses well fidelity resources to get reasonable responses. We'll discuss more about that. So our solution is either to teach the model, the Gen AI model, or train the model. When I say that teach the model, is connecting with scientific databases and resources such as RAG, tool calling, MCP, A2A. We'll briefly talk about that. Or you can take the model itself and change the model parameters like some last layer or something. So this is called training the model with LoRa and PEFT. And we can use a combination of both of them. But today we're going to mostly talk about the teaching the model with agentic AI. There have been really huge thirst from Google, OpenAI, and many other companies in the field to have a better agentic AI framework. And you can find details about this in this couple of technical guides from Google and OpenAI. I personally find this particular article a practical guide to building agents to be super useful if you want to learn about agentic AI. Also, predictive AI versus agentic AI. So, predictive AI, you might have seen you have an input and you get an output. For example, predicting the band gap, formation energy, predicting the classes from diffraction pattern, absorption energy, diffusion models, and so on. These are our predictive models. Agentic model is not just predicting a model, but achieve a goal. It's a multi-component system. It maintains a state, so it has predictive memory has no memory. It can have memory. It can have dynamical tool selection and self-refining loops compared to predictive AI models. So as I said, generative AI, you have a brain where it can produce content, uh, it can wait for prompts, but agentic AI can take autonomous actions. It's goal directed, so probably it's quite suitable for your self-driving course that Jay is teaching. Solve problem using tool and planning, can call APIs, search database, and run calculations. And we'll learn about this more. So let me start with a very simple example of counting R in strawberry. This is a super famous example how these models can hallucinate. So if you go to atomgpt.org, sign in with your Gmail or so other email address, and suppose there are many other models there, but suppose I am selecting GPT OSS, a Llama model, and a Gemma model from Google, and now ask the question, how many are in Strawberry? You'll be surprised to see that if we get three here for GPT OSS, two for Llama, and three for Gemma. So even for some of this super trivial, seemingly super trivial tasks, some of these LLM generative AI models can drastically fail, right? And of course, for material science, it's more challenging than that. So how can we solve this problem? We can make an API. What is the API? Is basically a function, a Python function or other code function hosted in cloud. That's all API is in a nutshell. So if you ask the question, how many are in the word strawberry, you can write a Python code, count r, s string count.r, it will give you three. Now you'll host this on AWS or Google Cloud or whatever framework you have or locally. And then anytime the model asks the question like this, count r in a word, instead of LLM giving the word, it will direct its question to this API and then give you a response. So that's what makes it agentic. And this is how we make an agentic AI for a strawberry problem in a way. So in an agentic framework, we have the Python code, we execute the code, and then we verify the correct answer. And this is one way to reduce hallucination at a much lower cost. We don't have to fine tune the model. Most of our universities, especially, don't have the budget to fine tune a large language model. This is millions of dollars business. Not fine tune, but develop from scratch. We can probably fine tune some of the layers, but those are also expensive. But this agentic framework is super uh, efficient as well as least expensive to reduce hallucination. Now, if you talk about material science specifically, things get much, much difficult. Why? In material science, we deal with heterogeneous tools like multi-scale modeling, like DFT, MD, finite element, and so on. The output format for different experiments like TEM, SEM, Raman, XRF, they have different formats. They all talk in different languages. Reproducibility challenges. Other fields like computer science seem to be more reproducible, while for material science, if I ask you to reproduce a 99.99% aluminum oxide all the time, good luck with that. It's very hard to generate a reproducible agent. So these are some of the problems, and also combinatorial challenge. Uh, we have really a combinatorial explosion with periodic table. So designing new materials is hard, or even designing existing materials could be hard. So let alone building an agent, right? So this makes application of agentic AI for material science super difficult and super challenging, but there is a hope. Let me show you an example of real form material design, right? So here what's going on is in this movie, we are trying to, or not me, but Iron Man is trying to design an arc reactor with lanthanides and actinides. So what he's doing is he is going through the same structure property relationship and designing a new material and testing it many, many times, failing all the time. But suppose if you had to do it in one shot, right? It won't be possible. Suppose you ask ChatGPT or something else, like design me arc reactor for Iron Man. It will probably come up with something, but it won't be validated. If you want to validate it, if you want to get a reasonable response, you'll connect with a reasonable tool like Jarvis or some um, uh, existing well known tool, well known database to get a reasonable response. And that's what makes agentic AI more reliable. Now, of course, there have been several efforts to accelerate material design, like Material Genome Initiative, CHIPS Act, and now there's a Genesis mission from US, which is pushing in the direction. There have been many, many projects that has come from this kind of initiatives. One of them, as Jay mentioned, is Jarvis, which we started at around 2017. It's available at jarvis.nis.gov, and you can find more details about this in the several literature we have. But basically, the idea is to use DFT, force field, machine learning, and combination of different apps um, to design or optimize a new material. Now, in 2025, we're also launching this atomgpt.org. We were very fortunate to have good traction for this project. We have over 200,000 users, about 6,000 citations, 50 articles. and thousands of citations worldwide. So now this was the overview of the agentic AI and database and Jarvis. Now we will go to a real world agentic AI for materials called ChatGPT Material Explorer, which led me to the design of Atom GPT. So in 2023, November 6, 2023, Sam Altman, who is the CEO of the company OpenAI, launched this thing called Custom GPT. And I actually learned about it in November 2024, a year later. So I was very interested about this. You can make your own GPTs for custom dataset and custom tools. So if you go to ChatGPT, on your left-hand side, you'll see something called Explore GPTs. And you'll search Material Explorer, and then my ChatGPT Material Explorer will come up. And the idea is you can make your own ChatGPT with some custom instruction and custom action functions and with some examples. You can find more details about this in the paper I wrote, but I'll show you an example where if I ask the question, retrieve all the materials from aluminum oxide in ChatGPT Material Explorer, see it's a part of ChatGPT, instead of making its own response, it's talking to Jarvis and then giving it the response. And that's one direct way, obvious way to reduce hallucination in ChatGPT response. So that's an obvious example of agentic AI. We also benchmark this with other frameworks like ChemCrow, GPT-4o for several tasks like IUPAC name, get the formula and predict the properties of materials. And we found for some it might work, for some, especially for very specific material design tasks, some of the commonly available tools like GPT-4o may not work. And that's why we need agentic AI framework to integrate with existing tools. Uh, and it made a lot of news out there. A lot of people made really amazing videos about this. It was well received, and Johns Hopkins actually made a huge announcement about this tool. So this is not just the only thing, ChatGPT Material Explorer. There are many other efforts of agentic AI. So you might have heard of co-scientists from Gabe Gomez group, Cam Crow from Philip Walker group, Elegante from your University of Toronto, uh, Atom Agent from MIT, LAMP from, I believe, from Materials Project or people, SciTool Agent from Chen, and of course our AG API agent that we'll discuss today as the major thing. So now let's talk about the atomgpt.org. It is available at this website, and that's how the homepage looks like. You can sign in with your Gmail. It provides 8+ open source LLMs. So one of the problems with ChatGPT Material Explorer is it's using private model, it's using proprietary model. So um, it may not be reproducible also. So we want open source model that we understand, we have control over, and then we can add tools. So it can search material databases, this atomgpt.org, predict properties, do X-ray diffraction pattern, literature search, and chat data is not stored. So unlike ChatGPT Claude, where data is constantly being used, even if you agree or don't agree, that data is being used for constantly training the model. We don't believe in those kind of thing. We delete your data and so on, and never use it for training. So that's a private ChatGPT, you can call it. It's totally free. You can access it your with your email account, and also comes with a feeling of features like function calling, model context protocol, and so on. Currently, we have 3,000 users in just few months, and a documentation about AGAPI is available at github.com/atomgptlab/AGAPI. So the key design principles of AGAPI is the following. So AI agent can be considered as brain plus API hands plus orchestration. Suppose you ask the question, study the effect of nitrogen substitution in silicon carbide semiconductor. First, find the 3C. 3C is a particular phase of silicon carbide in Jarvis DFT database, reports its property, then make a supercell and substitute a carbon with nitrogen, visualize and optimize with AlignFF, show the X-ray diffraction pattern, STM images, predict the properties with Align, and then predict the band structure with Slaconet. Then develop a script for quantum espresso calculation, do a literature research from archive and cross-ref, and draft a report. That's like a one task that we used to give it to the maybe undergrad student who does internship, right? When I was a grad student, this kind of a task. Now we can do as a prompt. Now, when we give this kind of prompt, what happens is we can use one of the brain. So in the ChatGPT Material Explorer, it was ChatGPT model, but in AtomGPT here, it's all open source models such as GPT, OSS, Llama. These are all open source model, DeepSeek model. You can select one or any of these. Then you have tools or hands. These tools can be Jarvis DFT, Slackonet, Align, and other tools or other knowledge bases. So what will happen is if you ask a question like this, first the model, the GPT, OSS, or other open source model will decide which model to call, which tool to call. Okay, then it will call the tool, get the response from it automatically or autonomously, and then get the make a summary out of it and then give you the response. So you don't have to write if do this, then do this, else do this. No more if else statement. It can do this autonomously. This is the documentation of the AG API. You can go to atomgpt.org/docs and you can see all kind of get post function and you can directly link with your supercomputer or experimental thing if you like to. Um, yeah, as I said, you can go to your atomgp.org. If you make an account, go to settings, go to account, get your API key. Don't share API key. Don't share anyone with your API key, and then go to /docs, and you will be able to see a lot of features that and is being constantly updated as like protein folding, powder excess diffraction, archive search, weather search, as a simple example. Um, so there are many tools being developed, and in my group at least, anybody who wants to graduate, they have to add at least one tool. That's my minimum criteria to have a PhD. To have something really useful out there rather than just, I mean, publishing paper is great, but I believe we should develop something useful for the community. So let me show you how to interact instead of website, how to interact on your Jupyter notebook or Google Colab notebook. So first you install this package like pip install AG API, and then put your API key that we got it from the previous step. And then you can ask a question like, what is the capital of US? Now, instead of going to the chatbot directly or website, you can do it at a command line. So that's the advantage of this API. Remember, this is still not agentic AI. This is still just plain LLM-based response. Now, suppose I ask a question, find all aluminum oxide materials and use tools. Then it will interact with Jarvis and then give you all the responses. Okay? But if you put use tools false, then it will give you response from the model itself. So it can make up all kind of IDs, all kind of formation energy, and then you can compare the degree of hallucination in a way. This is a query database search. You can also, as I said, you can run it on the website too. But I feel like most of the developers or experts try to use the API version of it. You can just go to the node pip install AG API and call the get the response from there. Another examples of search are like find the all materials with superconductors in Jarvis DFT. So we got 1,000 materials. Get the postcard, which is a crystallographic information of a particular ID of a material like silicon. You can get it from there. Suppose you want to compare materials, like compare properties of silicon, silicon carbide, silicon germanium. So it's retrieving the tool is getting the data from Jarvis about silicon, silicon carbide, and silicon germanium, comparing it. You see, it's making the report for you and then giving it to you. So that's the advantage of agentic AI. Instead of you downloading one by one material or getting one by one material and doing the comparison, it can do that for you. So there's advantage of this kind of model. You can also, for example, take a material and predict the properties using Align, and then like formation energy, band gap, bulk modulus, shear modulus, superconducting transition temperature, piezoelectric dielectric constant, and so on. You can do the same on the website, so I'll skip. I'll not go in details of Align and other graph neural network framework because you can, if you are interested, you can learn from this paper. You can also carry out something like machine learning force field-based optimization of atomic structure. So you can just put atomic structure and you can ask optimize structure with AlignFF and you'll get the optimized structure. You can get a band structure of a material using Slackonet. So you don't have to write WASP and other quantum espresso software, you can just use this kind of machine learning based model to predict full electronic band structure. This is a very detailed example of how one agent versus multi-agent tasks look like. So here I'm asking, find all the materials like nitride, get the postcard of the lowest formation energy, make a 2 by 1 by 1 supercell, substitute a gallium with aluminum, generate its powder X-ray diffraction pattern, report 10 XRD peaks, optimize the structure, predict the properties, calculate band structure, then create a summary table. Now, this is all in just one prompt. It will take few seconds, but it will do all the task and then give you this nice looking band structure with atom projected density states, band gap, and very detailed information on what it did. Yeah, so same with machine learning force field we talked about. I'll just skip. Another is suppose you want to make a heterostructure. So defects, like I showed you an example of substitution, and interfaces or heterostructures are core of material science. So suppose you want to find all gallium nitride, find all aluminum nitride, make an interface of 001 with this much thickness, and here you go. This is the heterostructure to generate directly from the command prompt. You can do X-ray diffraction analysis to find all the materials of gallium nitride, find most stable structure, use copper K alpha, and report me the 2 theta intensity peaks just from the command prompt. It can do literature search for you. Nowadays, I think when we started this project, at that time, ChatGPT 3.5 was making up all kind of references. If you remember, there was a time. It has gotten better now because it can do agentic AI. It talks to Google Scholar or Archive to get reasonable papers, right? So it can even atomgpt.org can do that for you. Now let me talk about an aspect of benchmarking this agentic AI models. So we started this benchmarking with well-known materials. So now, if you want to benchmark agentic AI, remember we talked about agentic AI has a LLM as brain, its hands as tools, and then its orchestration. So if you want to benchmark, you have to benchmark on these three aspects of the models of the framework. So what we did is you used something called Jarvis Leaderboard is a benchmarking platform, and there's an experimental band gap, bulk modulus, superconducting transition temperature, dielectric constant, and solar cell efficiency data. What we did is we know the experimental values, and then we get the responses from pure LLM and with tools and without tools. Okay, so with API and without API. What we found was a bit counterintuitive, which is quite surprising to me, but I guess it makes sense. We found that the tool automation augmentation is not universally beneficial. Sometimes these models have been trained on books and other data sets that we can get really good response from these LLMs. So if suppose you are predicting superconducting transition temperature, sometimes we found that without tool, the MAE was lower compared to with tool. Why? Because with tool, we are trying to interact with a DFT database of superconducting transition temperature. Now, DFT-based superconducting transition temperature is very slow and often not that accurate. Okay, so it's usually the MAE, mean absolute error, is 3 Kelvin, while data that come from the LLM itself is coming from the textbooks or some other well-known resources like Wikipedia. There you'll see that the MA is low. So we have to be sure that in the agentic AI framework, we don't just because it's agentic AI, it will be better result. It's not guaranteed. That's why we have to do benchmarking and do some sort of testing. However, this may not be true for materials which do not exist in the literature. So it depends whether the material and its properties are well known in the literature. If it's not, then these LLMs will either say, I don't know about this material, or very often they'll make up the numbers. And that is where I think the agentic AI tool calling may become important. We found that except bulk modulus, which we got MA of 5.7 GPA versus 7.8 GPA without tool, all other properties, agentic AI actually was not that good. Why? Because these were well-known materials. However, we are now testing this for other classes of materials which may not exist in the paper like Wikipedia, and then we will see where we expect that there the model agentic AI model which will be more useful, right? So these are some of the aspect of agentic AI benchmarking, and still a lot of thought is needed, especially because material design specifically is a very challenging task. So one way to do this kind of benchmarking and learn from each other is this agentic AI hackathon we started. We did this about a few months ago in January. We had about 120 participants from Data Science and AI Institute, from a lot of undergrad and grad students. We'll be doing it again, so keep an eye, um, and then you'll be able to learn about it in the next chapter of agentic AI. And yeah, in this agentic AI hackathon, what we did is we asked students to use one of these eight open source models, eight or nine open source models, use the tool calling like get weather, get materials from Jarvis or some other data sets, get papers from literature, and make your own tool from scratch. So these was a good learning lessons. Students really enjoyed it. Um, and this was a Jupyter notebook. You can still available on Atom GPT Labs/AAI for Science, where students learn how to build agents using this OpenAI agents framework and AG API. So yeah, if you are interested, you can feel free to check it out. Yeah, again, I'm happy to answer and go details about any of the aspect. Unfortunately, we don't have too much time to go in details, but we'll try to answer as much as we can. We'd like to thank the group members we have in the currently Jay, Justin, Riz, and Kent, Akshaya. They're doing fantastic work. And also, we are looking for students and happy to collaborate on several topics. So I would like to summarize here and save some time for questions. But I would like to really emphasize the future is agentic. Depending only on chatbots like ChatGPT, Claude is not really good for material science. We need to have agentic tools integrated with it, get an uncertainty estimate with and without tools, and then get a response from here. Yeah, these are the papers we discussed: AGAPI, an open source agentic AI platform for accelerated material design on atomgpt.org. Um, ChatGPT Material Explorer is another one. This is the website, this is the GitHub page. I have a lot of YouTube videos on my channel. If you are interested to learn about AI for materials and so on, I'm also active on social media like LinkedIn. And if you want to know about events that I'm being participating in, like this hackathon or other workshops that I'm part of, then you can get more updates as well. With that, I actually ended earlier than expected. So, and happy to answer any questions if you have. Thank you.